Hi, today we're going to do number 1408, string matching in an array. So we're given an array of string words. Return all strings and words that are a substring of another word. You can return the answer in any order. So we can see in this example, we have mass, as, hero, superhero. But as is a substring of mass, and hero is a substring of superhero. So that's what we return. Here, for LeetCode, code, ET is substring of LeetCode, and code is substring of code, so that's what we return. In the last example, there's no substrings, so we just return an empty string. So one way we can do this is using brute force. And with this, we create res array that's going to store the answer. And here we do a nested loop and check if value is a substring of the other. If it is, push to res. And that's pretty much all. We return res. Here the time complexity is going to be O of n squared, since we're doing a nested for loop for this, but also times m squared, because we're going to check if a substring of one string is a substring of another string. So it works, m is the length of the longest word, and the worst case could be you can look at the entire character of the word versus the entire character of the word, both being the longest m, and that would be the worst case. Space complexity is going to be O of 1, since we're not creating any constant space. We're creating a res that's going to be returned. That's auxiliary for needed for this code, which will be O of n times m as well. But it's just going to be 1, because that's what we're going to need. That's the extra space needed, not including the value being returned. And then we can improve it by sorting it, since we know that if we check every combination, we're doing an inefficient check if we check if LeetCode is a substring of ET, because this is longer. It can only be a substring if it's shorter, so we can sort it out first from ascending length, and then do completely the same thing. We have here create res, loop it if it's a substring, but we can change how we do our nested loop to increase the efficiency. Here the time complexity is going to be O of n log n, but it kind of rounds up to n squares because we're still doing the nested loop. And here the space complexity is going to be O of n, since we can create in-memory n space to sort out based on the sorting algorithm we use. So even though this has a more space complexity, it's more efficient as it can scale. So more time efficient as it scales, because we're creating a more efficient loop. So I'll choose sorting as a way, but I'll show you both ways. So here we create const res, and that's what we're going to be returning. And now we sort it. So words dot sort a or b by length, so a dot length minus b dot length to get ascending lengths. And now we do a nested loop for let I equals 0, I is less than words dot length I plus plus, and here is going to look at the next word, so we can just do minus 1 here. And now we do for let j equals I plus 1, j is less than words dot length j plus plus. And here we can check if the j word that includes the parent I, we can push the I word to it. And we know that word is going to be a substring, so we don't have to check it against the rest of it, because as long as it's one substring of one of the words, we push it so we can break out of it. Great, so that's one way. So the brute force way, we start off the same, where we have this res, and now we do a nested loop, but this time we have to check every possible combination. So we do let I equals 0, I is less than words dot length, I plus plus, and for let j equals 0, j is less than words dot length, j plus plus, and we can do a check here if we're looking at the same index value of a word. We can skip it, so we just do continue. Otherwise, we do the same thing if words j that includes what we're looking at, the parent of I. Res dot push words I to it, and then we can also break out. That should be j. Great, so that's two ways we can do it. Basically, same idea, we have to iterate through these words and check if it's a substring of another. We can improve the efficiency by sorting it first, and then with that, we can skip a check where we know it won't work if the word has a longer length of another word. And that's all. Thank you.